Hello everyone. Today we are going to see types of generative AI models. So before we get started, do check out my previous video on generative AI models on my YouTube channel. So let's see what are the types of Gen AI models. So there are different types of generative AI models. Each has its unique capabilities and applications. So to keep it simple, we have summarized into four types. One is generative adversarial networks, then variational autoencoders, then transformer models, and restricted Boltzmann machines. So now let's look at each of these. How do they work in brief? Okay, so let's look at generative adversarial networks. So it was designed by Anne Goodfellow in 2014. It is a combination of two neural networks. One is a generator and discriminator. So generator generates new data instances, whereas a discriminator evaluates them against a training dataset to find out whether the data generated by generator is real or fake. So in the process of training, in the initial process of training, generator generates absolutely fake data. Then discriminator will be easily able to identify that it's a fake data and flags it and sends that feedback to generator. Then generator learns that and tries to generate I mean, another random input uh, closer to the real one, but again, uh, it tries. So this loop continues till finally generator generates data that is almost closer to the real one, where discriminator tells that okay, this is real one. So even discriminator gets fooled that whether it is real or fake. So this loop continues and generator learns to generate more and more realistic data, and discriminator learns to identify whether it is real or fake one. So this process between a generator and discriminator is called adversarial process. So here is the picture of whole system. So here you can see generator generates new data hoping to be correct, and a discriminator, it tries to differentiate between a real and fake one. So these two networks undergo an adversarial process. That's why the name adversarial. So where the generator generates data closer to the real one, and discriminator learns to differentiate whether it is real or fake one. So this process continues until generator produces more and more realistic data which is closer to the real one, and at some point discriminator is fooled uh, that whether the data generated is real or fake. So that much closer to the realistic one generator can generate while learning from the discriminator. So these are some of the applications of generative adversarial networks. So it can generate new samples of image datasets, creating something new that resembles an existing photographs. So it can also generate human faces um that look like real photos. So we have some AI tools that can that uses at the backend, that uses these models and generate use cases. So next we have cartoon characters. So these models can generate entirely new cartoon character and images based on your input prompt. Then it can translate image to image, so it can translate image from one domain to another domain. For example, you give horse as an input image and ask them to convert to a zebra, then it can translate to that. So uh, it can convert sketch to a colored images. Also, it can convert text to image translations. For example, you give a prompt, a textual prompt, and ask them to generate some images, then it can translate it to image. Next, you have semantic image to photo translation. Let's say you have a semantic map of scenes, and if you ask the GANs to convert it, it can convert it to realistic photos. And next, you have a face aging. It can predict and generate images of a person's face as they would look when they are older. So these are some of the examples that can be used for creating realistic images. Can be used in voice generation, music composition, and drug discovery also. So the power of GANs, it's versatile. Okay. So now in the next type of model, we look at variational autoencoder. Okay, let's look at variational autoencoders. So this is the type of model that are particularly skilled at learning latent representations of data. So here is how it works. So we have input data, then we have an encoder, and we have a latent space, then a decoder, then the output. So this is the high level overview of how this variational autoencoder works. So uh, so let's look at each of these. So what is encoder? So encoder is the core of a variational autoencoders. uh, so an encoder, it's a neural network that learns to compress data. That is, it encodes data and then reconstruct it back to the original from decoding. So this is how you can see a sample in an image. Okay, then it also has variational aspect. So it is always a variational. So encoding it encodes each and every input as a single point. Also, like variational autoencoder encodes inputs as distribution over the latent space, which is represented by probability distribution of possible values, not just single values. So here you can see in the latent space, it you know it is represented by probability distribution of possible values for each of these attributes. So what is this latent space? So it's a compressed representation of input data. So in this space, VAEs, variational autoencoders, is regularized during training to ensure that it has good properties, which allows generation of new data that resembles the training data. Then we have reconstruction and regularization. So these are trained with two objectives. So one is reconstructing the input data as accurately as possible. Next is ensuring that the latent space has certain statistical properties. So so this is done by minimizing the loss function. So what are the one is reconstruction loss, then is another is regularization term. So let's see some of the applications of a variational autoencoders. So variational autoencoders has a wide range of applications in various fields. One of them is image generations. It can be trained on data sets of images to generate new images that are similar to the training data set. For example, trained on datasets like faces, it can generate variety of new faces with different features. So it can also work on anomaly detection. So it can be used to detect anomalies and outliers in the data. The idea is that normal data will have low reconstruction error, while anomalies will have high reconstruction error because they lie outside the regular data distribution. Okay, next we have drug discovery. So it is used in pharmaceutical, it can be used in pharmaceutical industries where VAs can generate new molecular structures for potential drugs. It can be trained on datasets of molecular structures, which learns to generate new molecules that are similar to that of those of training data set. So it can be used for data augmentation for existing data sets, and image denoising. VAs can also use for image denoising. The VAs is trained to reconstruct noise-free images from noisy inputs. We have seen here is this is an example. This is a noisy image, so it denoises that image. So variational autoencoders, it's a vast and varied, I mean it's which makes it powerful in the field of generative AI models. So if you want to learn more, or you can check out this blog. I can put this link in the description. Next, we have transformer models. So, it's a type of neural network architecture that has changed the natural language processing. So, it's unlike previous models that processed words in sequence. Transformer model uses mechanism called attention. So, uses this mechanism called attention to weigh the influence of different words. For example, look at this example, this sentence: the cat sat on the mat. So when you try to read it, so your brain tries to read this sentence as a whole. Okay, so your brain does not read it word by word. So instead it gives more importance to or attention to the words that give meaning. For example, cat and the mat. So the transformer model works similarly. It can look at all the word at once and decide which words are important, and uh, which words give a meaning based on the context. So there are some key concepts of transformer model. We'll look at them. So there was a paper released in 2017 by Google called "Attention is All You Need." So this paper changed everything in the generative AI space. so so what does it say? It states that a transformer is a deep learning architecture. So it was developed by Google on multi-headed attention mechanism. So what does it do? It uh, so the text is converted to numerical representation called tokens. Okay, and each token is converted into vector via looking up from the word embedding table. So you can understand this is like how computers understand text, like we understand each other words. So this transformer model is like a super smart system. It reads text and turns each word into a number, a kind of like a secret code. Then it looks at group of these coded words at a time, paying more attention to important words and less to others. This helps understand the meaning better. So imagine like this: if you're reading a story, the transformer focuses on the main characters and less on the background details. So this makes really good at understanding what's important in the text. So this technology has changed how computer understand language, making them way better at tasks like translation and answering questions. So it's like upgrading a computer's language skills from beginner to expert. Okay, so next we'll look at key concepts of transformers. So here are four key concepts of transformer. One is attention mechanism, next is multi-headed attention, next is positional encoding, then encoder and decoder. So combine these forms a transformer model. So we'll look at each of them. So first we have key concept is attention mechanism. So in this, attention mechanism is the heart of the transformer. So it allows the model to focus on different parts of the input sequence when predicting the each part of the output sequence. So much like you focus on different words in a sentence to understand its meaning. So for example, here you can see this sentence: the cat sat on the mat. So it focuses on the important words. So that's how this attention mechanism works. So next we have a multi-headed attention. Multi-headed attention, it's an extension of attention mechanism. For example, you can see each reader. So we have two readers. Let's say we have two readers who are reading the same sentence. So each reader might be focusing on a different aspects, such as reader 1 might be focusing on grammar and emotion, reader 2 might be focusing on subject matter. So multi-headed attention does this by having multiple heads looking at the input from different perspectives. Okay, so this is what the multi-headed attention is. So let's look at positional encoding. Okay, since the positional encoding, so since the transformer does not process the words in order, so it needs a way to take into account the position of each words. So it wants to find out where each word is, that indicates its position in the sequence of words. So this is how positional encoding happens. So if you want to understand in more detail, you can check out this blog on positional encoding. I will paste it in the description. So next we have encoder and decoder. So the encoder and decoder, so the transformer model has two main parts, which is encoders and decoders. So encoder reads the process, and encoder reads and processes the input text, and decoder generates the output text. So each encoder and decoder consist of multiple layers of attention, and it feed forward neural networks. For example, let's say you have an input: I'm a student. So it takes encoder takes that input and converts it, and translates that I'm a student into some other language. So encoder reads entire sentence and create a representation that captures meaning of each word in context. Next, decoder generates the translation one word at a time using attention mechanism to focus on different parts of the input sentence as needed. So this was encoder and decoder in brief. How does it work? If you want to deep dive into more details, you can check out this blog, the transformer model step by step breakdown. So I will put this link in the description. So, in summary, the transformer models have been used to create powerful language models such as GPT, generative pre-trained transformer, and BERT, bidirectional encoder representation from transformers. So, as you know, Chat GPT, which have taken created his first model after release of this paper. Attention is that all you need. So this paper has bring a massive change in this industry. So uh, transformer models can perform wide range of NLP, natural language processing tasks. So this was in brief about transformer models. So next we look at restricted Boltzmann machines models. So the restricted Boltzmann machines, it's a type of neural network that is used in unsupervised learning. So it consists of two layers. So one is a visible layer and other one is hidden layer. So visible layer, it's a input layer where you feed data, and the hidden layer is it learns to represent the features of input data in a way that captures the underlying patterns. So restricted part means that there are no connections within a layer, but connections only between the layers, as you can see here. So how does it work? So consider movie ratings of different users. So user 1, user 2 and user 3. Each user's ratings can be represented as a vector where each element corresponds to a movie and the value represents the rating given by that users. So visible layer is 5 units and one for each movie. Okay, so RBMs will try to learn the hidden parts in these ratings, such as which movie tend to be liked together using the hidden layers. So RBM uses visible layer to predict the hidden layer and then uses the hidden layer to reconstruct the visible layer. So this process is repeated many times, and weights between the layers are adjusted to minimize difference between original input and reconstruction. So after training, hidden layer might learn the features like hidden unit. Let's say hidden unit 1 activates when user likes action movies. Hidden unit 2 activates when user like uh, other uh, kids movies. So if new user comes and rates couple of action movies highly, the RBMs can predict that they will also like other movies that activate the same hidden unit. Okay, so what are the uses of RBM? So it is used in recommendation systems, and it's used in feature extraction and dimensionality reduction. Okay, so these are the places where uh, RBMs can be used. Okay, so far we have seen types of generative AI models. So overall, these are the generative AI models that fall under four categories. So to simplify these, we can say types of uh, generative AI models are. So one is language model, and the other one is generative image model. So one is generative language model and other one is generative image models. So generative language models learns about the patterns in language through training data, then give some text, they predict what may come next. And when it comes to generative image models, they produce new images using techniques like diffusion. Then, given a prompt or related imaginary, they transform random noise into images or generate images from prompts. So, why do we need to learn all these types of generative AI? Generative AI models. So why do we need to learn all these types of generative AI models, or at least know them? How do they work? So because ultimately we need to give prompt to the models and get our output. So we need to properly understand how do they work. So that way we can give proper prompting to the models and get our output. So that's it for today. I'll come with another topic in my next video. Until then, bye bye. Take care.